Hi, welcome to this lesson on number patterns, geometric sequences. We're going to look at this problem on solving a geometric sequence problem, question 6. So we're given that the first three terms of a sequence are arithmetic, and the last three terms are geometric. Find the values of x and y, so already that keyword of values, so there could be more than one, of x and y, if both x and y are positive integers. Now that is a crucial piece of information, because when we do our problems, if we see that one of the values for x and y are not a positive integer, then we need to discard that solution. That's very important, and a lot of people will skip that part there at the end because they think, well, there's no real relevance to that. But in any mathematical problem you're given, if you're not using 100% of the information at your hands, then you are missing something, and most likely you will have a missing piece of the solution. So let's analyze the first three terms here. We know that this is an arithmetic sequence. X plus 1, 3x plus 1, and 2y. Well, what do we know about the properties of an arithmetic sequence? Well, we know that they have a common difference. So this is term 1, term 2, and term 3. T2 minus T1 gives you 3x plus 1 minus x plus 1. So if I expand that negative into the brackets, I get 3x plus 1 minus x minus 1. The plus 1 and minus 1 will cancel. 3x minus x is just 2x. T3 minus T2 is 2y minus 3x plus 1. Notice how I put it in brackets, because when I'm subtracting that entire expression, that subtraction needs to be distributed evenly into the brackets. So if I do that, 2y minus 3x minus 1. Now, we know that these are all the common differences. So that first common difference there, we can therefore say for the arithmetic sequence that 2x must equals 2y minus 3x minus 1. What I'm going to do is I'm going to bring this 2y over to the left, and I'm going to take that 2x over to the right. So I'm going to subtract 2y from both sides first, or rather, actually I'm going to leave the 2y on this side. Yes, let's leave the 2y on this side, because then it's positive and it stays there, and we'll just move over the negative 3x and the negative 1. So I'll have 2y equals. So if I add 3x to both sides, 2x plus 3x is 5x. And if I add 1 to both sides, I get positive 1 there. So I'm just going to leave it like this for now. I'm going to call this equation 1. 2y equals 5x plus 1. Normally, we would divide by 2 just to get y by itself. But there's a special reason I'm going to leave it as 2y, and we're going to see why now when we look at the next equation. So the geometric one, that is the last three terms, which are these three terms here. So let's put it there. 3x plus 1, 2y, and 9x. Well, what are the properties of a geometric sequence? Well, one of the important properties we discussed is that there's a constant ratio. So if I do t3 divided by t2, I get 9x divided by 2y. If I do t2 divided by t1, I get 2y divided by 3x plus 1. Now these must be equal because these are the constant ratio. Just like these were equal, they were the constant difference, or the common difference. So for the geometric sequence, I have 2y over 3x plus 1 equals 9x over 2y. So let me first cross multiply both sides by this 2y on the right. So I'm going to get 2y times 2y. And then this is over 3x plus 1. And since I multiply by 2y on the right, I'm just left with 9x. Then I'm going to cross multiply both sides by 3x plus 1. Therefore giving me 2y times 2y equals 9x times 3x plus 1. Okay, and this is going to be called equation 2. Now, if you look at equation 2 on the left-hand side, you have 2y times 2y. Now, this is why I left the arithmetic sequence in equation 1 as 2y. Because now I've got an expression for 2y in terms of x. So what I'm going to do is I'm going to substitute equation 1 into equation 2. So let's have a look at that. So I'm just going to rewrite equation 2 below here. So it's going to be 2y times 2y, and that was 9x times 3x plus 1. All right, let's double check. Yeah. Okay, but we know that 2y is given by 5x plus 1 from equation 1. So substituting that on the left-hand side, I get 5x plus 1 times 5x plus 1 equals. On the right-hand side, I'm going to expand this out. 9x times 3x. 9 times 3 is 27, and x times x is x squared. Then 9x times positive 1, that's just going to give you positive 9x. Okay. On the left-hand side, I'm going to expand out the brackets using FOIL, the distributive law of algebra. 5x times 5x is 25x squared. 5x times positive 1, positive 5x. Positive 1 times 5x, positive 5x. And positive 1 times positive 1 is positive 1. That's equal to 27x squared plus 9x. All right. So now I need to get everything on one side. I think I'm going to bring all the terms on the left over. But before I do that, let's clean up this. These are common terms here. 5x plus 5x is 10x plus 1 and 25x squared. That's equal to 27x squared plus 9x. Okay, so now I'm going to bring all these terms on the left over to the right. So 27x squared minus 25x squared. Notice I'm doing common terms or like terms together. The 27x squared minus 25x squared is just 2x squared. 9x minus 10x leaves you with negative 1x. And this positive 1, when you bring it over, becomes negative 1. And that's all equals to 0. Now this is a quadratic equation of the general form, ax squared plus bx plus c equals 0. So the factorizing techniques we've learned, how do we solve this? Well, we can try and factorize it, right, by trial and error method. We could use the quadratic formula for a, b, and c values that we have here, or we can try and complete the square. So let's try and factorize this, right? Factors of 2 are just 1 and 2, and the factors of 1 are just 1 and 1. So we want the pair that'll give us negative 1 here in the middle, right? And also when you multiply them out, give you negative 1. So let's see how we do that. Well, we can go 1 times 1 and 2 times 1. So 1 times 1 is 1, and 2 times 1 is 2. Now if I do 1 minus 2, I get negative 1. That gives me that negative 1 term here in the middle. So I would say my two factors are going to be, so for the factors for 2, it's going to be 1x and 2x, right? 1x and 2x. And we said that it has to have a 1 and a negative 2 in here. So let's try 2x plus 1, and let's try x minus 1. This is the trial and error method. So the terms you put in here, we're going to have to try expand out and see if they work. Well, if I have a quick look at this, x times 2x, that's 2x squared. Right? Then x times positive 1 is positive x. Negative 1 times negative 2x is negative 2x. And negative 1 times positive 1 is negative 1. That gives me 2x squared. X minus 2x is negative 1x and minus 1. So this is the correct factorization. And you can set that equals to 0, right? And now you've got your factors. So I will therefore set this factor equals to 0. X minus 1 equals 0. Therefore add 1 to both sides. I get x equals 1. Or set this factor equals to 0. 2x plus 1 equals 0. Subtract 1 on both sides first. So I get 2x equals negative 1. Then divide both sides by 2. And I get x equals negative a half. You could have also used the quadratic formula here. So let's recall x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, my a value is 2, my b value is negative 1, and my c value is negative 1. So if I plug those values in there, negative, open brackets, negative 1, plus or minus square root of -1 all squared minus 4 times a, which is 2, times c, which is -1, all over 2 times 2 times 2, because that's a. So therefore the two values for x are going to be, so my calculator, let's bring that up, and we will see that. So let's do the positive one first. Okay, so let's put our brackets there, -1, positive, so plus square root of -1 squared minus 4 times 2 times -1, and then underneath that 2 times 2. So I get x equals 1 for my first solution, or if I bring up the calculator again, I'm just going to go up and edit that and put the plus before the square root as a minus, and I get -1/2. So you get the same answers. Okay, so whichever method you prefer of doing is the method you should go for. Right, you won't be marked incorrectly if you factorized it like this or if you did the quadratic formula. Now, let's remember that very important piece of information given to us at the start. X and y are both positive integers, but I just found two x values and one of them is -1/2. So first of all, it's not even an integer, it's a rational number, and it's negative. So we have to discard that solution, not applicable. So x equals 1 is the solution we're most likely going to be looking at. And how do I find the associated y value with this? Well, remember, from equation 2, I can use this equation to find y. So I know 2y equals 5x plus 1. So I get 2y equals 5 plus 1 is 6. Divide both sides by 2, and you get y equals 3. So my xy pair is when x is 1, y is 3. But I'm not going to stop there. We are good mathematicians. We will go back and check, does this solution actually make sense? Well, if I look at the setup we were given, right, the first three terms form an arithmetic sequence. So I know what my x and y values are. So let's just clear up here. And let's recall, we found that the xy pair was when x is 1, y is 3. So let's put that in here. 1 plus 1 is 2. 3 times 1 is 3, plus 1 is 4. 2y, 2 times 3 is 6. And then 9x, 9 times 1 is 9. So, the first three terms of the sequence, 2, 4, 6. We were told that this is arithmetic. And this is true, right? There's a common difference of plus 2 in the sequence here. Okay, so my common difference d here was positive 2. What about the last three terms? 4, 6, 9. Is this a geometric sequence? Well, let's test it out. 9 divided by 6 is t3 divided by t2. Well, 3 goes into 9 3 times, 3 goes into 6 2 times. So that simplifies down to 3 over 2. So this is t3 divided by t2. What about t2 divided by t1? That's 6 divided by 4. Well, 3 goes into 6 2 times. Well, sorry. 2 goes into 6 3 times, and 2 goes into 4 2 times. So that's the simplified form. So therefore, my common ratio value is 3 over 2 here, verifying that this is a geometric sequence that we were given. So therefore, the final solution would be this positive integer pair here, x is equal to 1, and y is equal to 3. And that is how we will solve this type of problem. Lots of algebra techniques being used here, factorizing, using the quadratic formula, using simultaneous equations and making the correct substitutions, and then going back and verifying. So no matter what part of mathematics you're doing, your algebra will always be there in the background, and all the techniques we've learned will be continuously applied throughout each problem. Okay, I'll see you in the next one.